Hey guys, in today's video we are going to solve one more Leetcode question, that is question number 26. Remove duplicates from sorted array. So this is one of the most popular questions because this has been asked by so many organizations. We can see in last 6 months this has been asked by Amazon, Apple, Adobe, Facebook, Google, Microsoft, etc. So let's see what this problem is all about, and we will also be solving this question using two programming languages, that is Python and Ruby. If you're not interested in both the languages or any one of the programming languages, then you can choose the part that you are interested in and can proceed with that. So let's see what this question is all about. So in this question, we are provided with an array nums, which is a sorted non-decreasing array, and we have to remove the duplicates in place such that each unique element appears only once. And we also have to maintain the relative order of the elements and have to return the number of unique elements in the nums. So there are few things that we need to consider before coming up with a solution. So the first thing is we have to change the array nums such that the first key element of nums contain the unique elements in order they were present in nums initially, and rest of the remaining elements of num are not important, as well as the size of nums. So we don't have to take care of rest of the array size or elements. We only have to concentrate on the k elements, which are the unique ones, and then we have to return k, which is nothing but the number of the unique elements. So let's see how we can solve this question and try to understand it using this example, where the input is like 0 1 2 3 4, where 0 1 2 and 3 are having their duplicates. So we will be removing the duplicates from this input array in place, and it will become something like this, which is the output we can see here. So there will be 0 1 2 3 4, and rest of the elements are something we don't have to be concerned about. So how we can come up with a solution, but before directly coming up with a solution, we should always focus on the properties of the input or the helping hand that comes with our input. So in this case, we are having few helping hands, like firstly, the input is in sorted order or is in sorted manner. Then second thing is we only have to concentrate on the k elements, that is the unique one, right? Third thing is that we have to do this whole duplication removal in place. So we are not allowed to create a new array and add the unique elements in that array and then return it. We have to do everything in place. So now we are having these three properties, and we have to propose a solution using our input and these three properties. So how we can solve this? And the first approach that I can think of is two pointers approach. Why? Because as we can see that our input array is in ascending order or is already sorted. So in that case, what we can do is we can create two pointers, and we can simply compare that if the previous element is equivalent to the current one, in that case we know that this one is the duplicate of the previous one. This is not unique, and we only have to find the unique ones. So this would be easier for us to find all the unique elements. So now let's try to solve this question, two pointers approach. So I'll say that there will be two pointers. First one will be the insertion pointer, where I will be inserting all the unique elements. So let's say we will start traversing from here, because we know that the first element will be unique, of course, and we need to check the duplication from next element, right? First will always be unique. So we will be start traversing from here, and what I'm saying is there will be a inserting index. So let's call it as I in this case. So now what I'm saying is my inserting index is I, and what I will check whether the element at I is equivalent to the one which is present at the previous index. So what I will check is 0 equivalent to 1? So I know it is not equivalent. So I know that 0 and 1 both are unique elements. So what I will do, I will simply increase my insertion index. Now I will check whether my I is, now I will come up here. Now again I will check whether my I is equivalent to the previous element or the element at previous index. In this case I know that 1 is duplicated at index 2. So now what I will do, I will keep my insertion index as it is and I will increase my this traversal index and I will go to next element. This is again duplicate. I will go to this element. This is also duplicate and I will come up to this 2. Now I will check whether 2 is equivalent to the previous element. So this is not equivalent. In this case I know that 2 is unique. So what I will do, I will insert 2 at my insertion index and here it will become 2, right? And after this my insertion index will again increase and it will come up to this place and this is 2. Now again I will go to next element. My traversal index will go to next element. It is 2. I will check the element at previous index. It is same. So I will again go to next element, that is 3. Now again I will check the element at previous index, which is 2, and I know that 2 and 3 are not equivalent. That's why 3 is a unique element. So now again I will insert 3 at my insertion index, that is here, and then increase my insertion index. My insertion index will come up to this place. Then again I will proceed my traversal index. I will again check the previous element which is equivalent. Then I will again go to this element and I can see that 4 is not equivalent to 3, that is 4 is a unique element. And then again I will insert 4 at this place where my insertion index is, and at this point I can see that now I can't move my traversal index any further. It will go out of bound. That means we have traversed the whole array and we have transformed all these elements, duplicated elements, into the unique ones. So what will be the answer? Answer will be somewhat like 0, 1, 2, 3, 4, 2, 2, 3, 3, 4. And this whole array will be returned as a answer, and insertion index, that is I, what I is at this point, the value of I is 5. 0, 1, 2, 3, 4, 5, right? So insertion index is 5, that is the number of unique elements, or k in terms of question. This is the k value and this is the in place duplication removal. So we know that this is the only part which consists of all the unique elements, and rest of the elements are as it is and we don't have to take care of it because we have to only remove the duplicates. And we can see that in this question what we are asked is we only have to return the array with correct length, or the length which is equivalent to input, right? So we only have to take care of the k elements. So this was the whole solution, and right now the screen is quite messy. Let me just clean it a bit and then we will see the time complexity and space complexity of this whole solution. So this was the solution that we just calculated, and this will be the output. As we already saw how we came up with 2-pointer approach and we got this answer. So now let's see what will be the time complexity. The time complexity of this whole approach will be big of n, as we are traversing this whole array only once and the size of array we are considering it as n. So the time complexity will be big O of n, and space complexity will be big O of 1, because we are using only 2 pointers and they won't occupy any space, they are constants. So this is the time and space complexity of this question. Was a easy question? kind of straightforward one, but interesting one. Now we'll be writing the coding part of the whole approach. So firstly, we'll be writing the Python code, and after this, we'll be writing the Ruby code. Firstly, let's calculate the size, which is nothing but length of nums. After this, as we already saw, we need an insertion index, and this will be from 1, and then we will be running a loop in range size, and we will be checking if nums I minus 1, because our loop will be from 1 to size, so I minus 1 is not equivalent to nums I, then only we will be inserting, right? So in that case, what we will do, we will simply insert nums I and then increase our inserting index. So this is the only part that we need to change the elements in place, and then what we will do, we will return insert index. I might have done some typos. Fine, let's see this code works or not. Okay, let's submit this. Okay, we can see this has been accepted. Now let's write Ruby code. In Ruby as well, we will be doing the same thing. That is, firstly we will calculate the length. After that, we will define a variable name as insert index. Where is the t? And it will again be equivalent to 1. Then we will run a for loop where we are saying for I in from 1 to size minus 1, and end is must in Ruby. Inside this, we will again define the if condition that we defined over there, that is nums I minus 1 is not equivalent to nums I. In that case, what we want is, we want nums insert will become index will become insert index plus 1, right? This was the whole code, and after this, what we will return insert index. Let's see if I hadn't made any mistake. I think I did. Okay, I returned the insert index inside this for loop. That's why it was, yeah, now it's working. So I just returned the statement inside that for loop. That's why it was not giving the answer. So now I think it will work. Let's submit it and see. Okay, this has been accepted. So this was the whole solution and explanation of this question, and I hope this video was helpful for you all. And if you find it helpful, then you can like this video, subscribe my channel, and I will soon come up with few more questions. Till then, take care and keep messing with algorithm. Thanks for watching.